In this episode, we'll talk about why corners are the problem you never knew you had, and see what happens when two industrial designers literally think outside the box. Welcome to the Cool Parts Show.
The Cool Parts Show is brought to you by Carpenter Additive. The company's Athens, Alabama Emerging Technology Center is an end-to-end additive manufacturing production facility with everything from material development to post-processing under one roof, ready to help you with your next metal 3D printing job. Check them out at carpenteradditive.com. Now back to the show. I'm Pete.
I'm Stephanie.
Welcome to the Cool Parts Show. This is our show about parts manufactured through 3D printing. We talk about new stuff becoming available to us because of 3D printing. We talk about 3D printing and the meaning it's going to have for the future of manufacturing. And speaking of future, it looks like you brought us a dinosaur egg.
That's right, 3D printed dinosaur egg. That's our part today. Just kidding. This is actually a speaker cabinet. This is for a high-end consumer product. It's the Hylixa speaker from Node Audio, and this speaker solves a problem that I didn't even know speakers had. It has very few flat surfaces and basically no corners.
Okay, yeah, so speakers, typically, they're like cabinets, they're box-shaped, they have corners. I never realized that was a problem. Why are corners a problem for sound quality?
Yeah, so it's a problem because anywhere you have a corner is basically a place that the sound can kind of get trapped. So if you think about like being in a room with a rotunda versus one with a flat ceiling, like the way that the sound moves is different. It's going to go further, it's going to sound louder. And it's the same kind of idea here. So actually in use, the speaker would be like this, facing that way. And you can see that it has kind of this like spiral on the inside. So that means the sound can move through without hitting any corners. So I want to introduce you to the people who created this part, the co-founders of Node Audio, two industrial designers. So this is Ashley May and David Evans.
In scaling down a speaker, you lose a lot of the bass performance that you get from a large square cabinet. But these large square cabinets are also acoustically compromised. So we wanted to arrive at a solution that was acoustically far superior to what had gone before. So a good example with a cabinet, a square cabinet, you get resonances from the structure. So the panels vibrate, standing waves form in the panels, and that gives a certain coloration to the sound, a negative coloration. Also the square corners of cabinets, that creates a smearing and a type of diffraction, which negatively colors the sound, particularly in the vocal region. I mean, we don't have square heads, right? We've got rounded heads. So when the voices and sound leaves our mouth, it flows around our head in a particular way. And you can only achieve the accuracy and realism by replicating that sonic signature of a round head. So that was our starting point. But in doing so, you compromise the bass performance because you've gone from a large cabinet, which is really good at producing bass, to something quite small and limited in the bass region. So we set about figuring out how can we recover that bass performance. And that led us to a special acoustic geometry called a transmission line, which isn't a new theory as such. It's a way of extracting more bass performance from a cabinet. But the only way to get this long acoustic transmission line, which is essentially a path or a long acoustic channel inside the cabinet, was to coil it up in a sort of almost like a seashell shape.
That's true. I mean, yeah, it was obviously driven by the sort of function initially, but as designers, obviously we wanted to make this product look as good as it sounded as well. So
it sounds better because it's shaped like my head?
Yeah, that's a big part of it, but to really get everything that Node is after, you need more than the round shape. You need that helical transmission line, the spiral on the inside, to get as much sound range out of a speaker this size.
Okay, how did they know that? How did they know spiral on the inside? How did they know this is the right design?
So good question. Ashley and David worked with an acoustical engineer who was actually able to simulate how the sound would move through the different design iterations. So they used that simulation alongside the prototyping process.
There's some really excellent acoustic software out there that can give you a really good handle of what's happening in reality before you even press go and print a prototype. But what the prototypes were great for were validating those acoustic simulations. Actually made some really interesting discoveries by altering the prototype and then feeding that back into the acoustic simulation.
The entire sort of development stage of the product was probably, I think it was 3 years in total. So that was, like Ashley said, initially working with an acoustic engineer to simulate that design, and then coming back to us to then, prototype or tweak the design before, we went into production.
Okay, so that's really wild. So we've done episodes before about 3D printed parts where their form was optimized for forces and loads. Here is a part optimized for invisible sound waves. How was it 3D printed?
So this was 3D printed with selective laser sintering, so SLS, specifically on an S Pro from 3D Systems. And I actually have another part here that was made the same way. And this is kind of like the front face of the speaker. So both of these parts are made out of a material called Duraform GF. It's a polymer composite. It's glass-filled nylon, but it really doesn't feel like plastic. Like it has kind of like that ceramic quality to it. It's really heavy, solid, dense. And they chose it because it's not a very resonant material. So if you kind of knock it, there's no ring to it. Like the sound just kind of falls flat. And actually that's what you want out of a speaker like this, because that means the sound isn't vibrating the cabinet, the sound is moving through the cabinet out into the room.
So this is so cool. I'm totally in. So they used the design freedom of 3D printing, and it wasn't just geometric freedom. They got this form that's adapted to the acoustics, but they also employed the material freedom, the freedom to choose exactly what material they wanted to print with. And the right material in this case was this really dense, kind of ceramic-like material that has great acoustic properties, that has like no resonance.
Yeah, I guess we should say like this is not the entire product. Like there are other parts that go with this. There are other 3D printed pieces. There are machined pieces. There's the electronics. And actually the parts we have here are not even finished. Like there's a lot of post-processing that goes into this too. The cabinet is kind of the key, but it's sort of just the beginning.
A good example is the head of the speaker. So the rounded pod that you have there, that cabinet, it builds great. It's got fabulous acoustic properties, but when it comes off the machine, it's got that kind of grainy finish. And there are certain processes where you can smooth it. I'm sure you probably know about vibro polishing, but nothing really gets that finish to the certain level that we're after that justifies the price of the speakers and matches the acoustic quality. So we thought, well, hang on a minute. If we separate the components, so the neck section of the cabinet is actually a separate piece, and then we build the cabinet head oversize by a few mil on the outside, we can then put that part into a CNC lathe, and we can cut that part back to the finished accurate dimensions, so that when it goes off to the paint finisher, they've got a really good base surface to start their sanding and painting process. So it was putting in a few automated steps before it went to the manual finishing to really save a bit of money and actually achieve a better finish.
Okay, so they're machining this, and I wouldn't have expected that you'd machine this kind of ceramic-y polymer material. Does the fact that they know they're going to machine affect anything about the way they design it?
Yeah, so aside from printing it a little bit larger to accommodate for that finish machining, there are a couple of design tweaks. So right inside of this cabinet, on kind of the inner diameter, there are these little ribs. That's one example.
Obviously, every part from the SLS machine, there are very, very slight tolerance differences. So the aluminium mandrel that fits inside the mouth of the speaker, our engineer offers that up to each cabinet, and we built in very, very small ribs internally so that he can just tweak them and file them down so this mandrel fits beautifully snugly inside the cabinet. Otherwise, he'd be obviously fettling a large surface back. So it was just making intelligent use of those details to give the engineers and the assembly guys, the right sort of tools and the right processes to really make it efficient to mount it onto the CNC lathe.
Okay, so I think I got this. So, audio speaker. Audio speakers, we're used to them being cabinets, we're used to them being boxes, but the corners in those boxes were costing us something. That's not the ideal form for sound quality. The ideal form for sound quality? Something more like this. egg-shaped, but also with this seashell spiral on the inside that transmits the sound. That spiral and this form were designed with the help of an acoustic engineer able to model just the right form for that sound quality, a sound realized through 3D printing. This was 3D printed through Selective laser sintering on a machine from 3D Systems, and the material is important too. This dense, low resonance glass-filled nylon is important to the sound quality as well. Material and form both contribute to the quality of the sound. It's a work of art in addition to being an audio speaker. It's got to look good in the setting it's going to be used in. That affects the post-processing considerations. And one of the ways that this is post-process, or a part like this will be, to get a really smooth finish is through machining. And they even designed some features into this that aid in that machining. I think all that still leaves one question unaddressed. We've just got the part here. We don't have a finished speaker. How does this sound?
That is a great question. So this speaker has been on the market since 2019. I've never had the pleasure of hearing it in person. So I asked David and Ashley if they could describe what it sounds like.
So yeah, in terms of a clarity, a sound stage, it's quite, again, a cheesy sort of comment to make, but yeah, it is as though, you know, the artist is in the room with you, and yeah, it just sounds like, I suppose, a live performance.
Really, what we're after is an emotional response, and it's really lovely. We've got a listening room here, and when you sit people down who've never heard it before, it's great to, you know, watch their faces and see their first reaction when they listen to a track that they've heard thousands of times. But when they listen to it on this system, there's all these details and nuances and a level of realism they haven't actually heard before. So it's almost like listening to their favourite track for the first time again, and that's quite a nice thing to experience.
All right, so possibly coming soon to a living room near you. That's it for this episode of The Cool Parts Show. If you'd like to learn more about Node Audio and this speaker, you can find a link to a story in the description below. And if you have a cool part you'd like to tell us about, email us, coolparts@additivemanufacturing.media.
Watch more of The Cool Parts Show. Find our episodes on YouTube or at thecoolpartsshow.com, and don't forget to subscribe.
Thanks for watching.
Thank you to our sponsor, Carpenter Additive. Listen to additive manufacturing podcasts, attend webinars, and learn more at carpenteradditive.com.